This is for section number 4803. It's for college algebra, which is MAC 1105. We're in chapter 4. Well, the question's from chapter 4 anyway. And it was on section 4.1. They want number 38. Since this is a homework problem, I'm doing problem 37 as an example of 38. The directions for these are to find the zeros and to state the multiplicity. Alright, remember, when you're finding your zeros, you're setting your entire function equal to 0, and you solve for x. Well, you solve for the variable in the original formula anyway. The multiplicity is after you have it factored, something like this. Multiplicity would be the exponent on the factor, if this is a single x here. When you sum up all of your multiplicities, they should be equal to, so if you sum multiplicities, they should be equal to the degree of your polynomial, which remember is the degree of your leading term. Number 37's problem says f of x is equal to x raised to 4 minus 4x squared plus 3. So you might look at this and say, uh-oh, it's a 4 and a 2, and you're used to seeing a square and that unlisted 1 on your single variable. You would like to see that anyway, because then it'd be easy to factor or do your quadratic equation and solve for x that way. Okay, so what I'm going to do is make this first term in terms of something, you gotta find something that would be squared, so then you would have a 2 at the beginning. So x to the 4 is what squared? So if I put an x squared inside my parentheses, I square that, what do I do when I have a term raised to something and then all of that raised to something else? You take this number and multiply. So when you multiply these numbers, it should equal to a 4, and you wanted a 2 on the outside. What we're fixing to do is called u-substitution. But you can really pick whatever letter you want to. An A or a B. Try not to pick I. I'm going to go ahead and just use a U though, since that's the name of the game here. So I'm going to say u is equal to what's inside this parenthesis here. I'm going to make my u equal to x squared. So then in my original formula, everywhere I could have an x squared, I'm going to replace it with a u. So my x to the 4 is x squared squared, so this inside here is a u, squaring it. Then I have minus 4. Here's an x squared. What do I replace x squared with? The u. And then plus 3. Okay, so all of this, what do I do with that? Well, I wanted to take this entire function to find the zeros, take the function, equal it to 0. So I want to take this entire function, I would have took this entire thing and set it equal to 0. X squared minus 4u plus 3. Right, so one more time. Original was x to the 4 minus 4x squared plus 3. I took my x to the 4 and it became u squared minus 4, my x squared, once again, is a u, plus 3. Now this is 4 u equal to x squared. Now, do you think this function is still called f of x if my variable is a u? No. It's really f of u. So you have u squared minus 4u plus 3. I'm setting this entire thing equal to 0, and in this case I'm solving for u. So squared term, that term, number. Is it easily factorable? Are there two numbers of 3 by addition that can make a negative 4? Yeah, a 1 and a 3. Instead of saying xx, I'm going to say u. Now this needed to be a positive 3 and the inside needed to be a negative 4. So what two symbols, when you multiply them, make a positive? Well, you could have had positive positive or negative negative. We want a negative 4, so they have to be negative negative. So my outer, negative 3u, inner, minus 1u makes negative 4. And the negative 1 times negative 3 makes plus 3. So it's already factored now, equal to 0. So you're going to set each factor equal to 0. U minus 1 equals 0. U minus 3 equals 0. Solve for u in this case. U is equal to 1. U is equal to 3. Am I completely done with finding my zeros? Well, my original has x's in it. Have I found the zeros when it's an x? No, I've only solved for u. So that's where this comes in. U is equal to x squared. Everywhere I see a u, I'm replacing it with x squared. So instead of u is equal to x squared, I have, instead of u is equal to 1, I have x squared is equal to 1, because u was equal to x squared, and x squared is equal to 3. Solving for x now, how do you get rid of a square? Anything special about your square root? plus or minus the square root of 1. Same thing over here, plus or minus the square root of 3. And how many different answers is this if they both have plus minus? 4 different answers. Make sure you break it up. Negative square root of 1 is really negative 1. And then positive square root of 1 is a 1. Negative, square root of 3. Now, do not plug that in your calculator and do the rounding to 3 decimal places. Don't do that. Leave it in exact terms. If you could reduce this with a square root, go ahead and do that. But this is a square root of 3. You can't get more simple than that in exact terms anyway. So you gotta leave it as negative square root of 3, and x is equal to the positive square root of 3. Am I completely done with this problem? No, because they asked me to do some extra stuff. Find the zeros and state the multiplicity of each. Alright, so multiplicity of each of these zeros. Now, if we had just used, if it was like that, then it would be 1, 1 for the u. But it's x to the 4 in the beginning, so we need 4 zeros. Remember, when you sum up all of your multiplicities, it should equal to your degree of the polynomial. Each of these x's only occurred once. This is multiplicity 1, 1, 1, 1. Because if you didn't write u minus 1 and u minus 3, it would have been x squared minus 1, x squared minus 3. And these factor, well, x squared minus 1 is x plus 1, x minus 1. X squared minus 3, you could still do the difference of perfect squares. Because remember, you're just taking the square root of the front minus the square root of the back, the square root of the front, plus the square root of the back. Oh, I said that backwards, but it's still plus minus square root of the front in the front, square root of the back in the back. X squared minus 3, well, you know it's x and x here. This 3, you just do square root of 3 plus minus. So this is 1, 1, 1, 1 on your exponents. So your multiplicities are all 1. Alright, so if you're doing u-substitution, most of the time it's like that anyway. And this was college algebra, number 37 from the book. Homework. Now, 37 was an example of 38. And as always, if you have any questions, comments, or concerns, send me an email.